experiment from your group USPHP05 E by M by Thomson's method to determine the charge to mass ratio of the electron by Thomson's method. This is the aim of our experiment. Now theoretically this article you might have learned in the 12th standard or in first year. Experimentally we will determine E upon M. In order to do that, the experimental setup or apparatus which you require a cathode ray tube. This is a cathode ray tube, this one. Screen of the tube, here it is. Alright. Then this will be a required power supply. Magnetometer, wooden box on which the magnetometer should be kept. Then this wooden frame on which the magnets we are going to keep. So this one is there. So these are the required apparatus. This is the required apparatus for performing E upon M by Thomson's method. Now once you know the required apparatus is here, you can see here this is the apparatus we require. There are two parts of the experiment. First we will apply the electric field. Electric field will apply. So here you can see observations for the electric field. You will apply the potential difference between the plates, and when you will apply the electric potential between the plates, the spot which is there at the 0, when there will be potential difference applied will be 0, the spot will be at the center. When you will switch it on and you will apply the potential, so when you will apply the potential, so definitely there will be a deflection. How much deflection you should get, that also we have specified. I want the deflection of 0.4 centimeter, then 0.8 centimeter and 1.2 centimeter. For this much deflection of the spot in the upward direction, either upward or downward depending upon the direction of the current passing through the circuit. Now here 0.4, 0.8 and 1.2 centimeter deflections will be produced. How much potential is applied, that you can see on this digital panel. Now at present this power supply is not working, so you will not be able to see this here, but this digital display will give you the how much potential is applied, so that you will have to note down here. For 0.4 it is converted into meter, it is the deflection, it is 2.5 volt, then for 0.8 it is 5.5, then for 1.2 it is 9.8. Now by taking the ratio, theoretically you know the applied electric field will be equals to V upon D, you know V, you know D, V upon D will be the applied electric field. So this way the first part of the experiment you have to complete. Then the applied electric field which we have applied, that can be nullified. So here to nullify that applied electric field, you will take a magnet, put the magnets here on the wooden bench and adjust the distance on the magnet on both the sides of it. You can keep it the magnets, the distances of the magnets you adjust such that, so here you can see now the second part we are starting. For a magnetic field we are applying now. Now what will be the magnetic field, how you are applying the magnetic field? To nullify the applied electric field. Because of the electric field the deflection was produced. Now I will adjust the magnetic field such that whatever deflection was produced initially, that should become 0, and therefore how much should be the distance of these two bar magnets which are kept here to nullify this deflection of 0.4 centimeter. You keep the magnets at a distance of 18.5 centimeter from the axis of this CRT. Here the deflection which was 0.4 is nullified. Now whatever is the applied electric field is nullified by the magnetic field and the spot is coming at the center. Then for the second, here the deflection was 0.8. Now I will change the position of the bar magnet so that take the bar magnets close to it, the spot will come to the center. So corresponding distance of the magnets you have to note down. Then for 1.2, so 1.2 was the deflection, so that applied electric field, applied potential, you know 1.2 is the deflection. Here I will change the position of the magnet and try to make it 0. So what are the distances of the magnet? You know it is 18.5, 13.8, 11.3. Note down these distances. For these distances the applied electric field is nullified by applying the magnetic field. Now replace this CRT from here. And what is the applied magnetic field? We are just keeping the bar magnets here. So how much is the applied magnetic field? You can find out. So how will find out that? So put the magnetometer box here. And now note down the deflection produced here. So whatever will be the deflection produced, magnetometer reading for the distances. What are the distances? 11.3, 13.8 and 18.5. You keep the magnets at the with the same arrangement, the way we have kept for the nullifying the electric field, at the same distances you keep, and corresponding deflection produced in the magnetometer. So here for first it is coming 33, then for the second one it is coming 53, and for third one it is coming 67 degrees. You know this will be coming in the degrees. So that you have to note down. And what will be the applied magnetic field? It is B equals to BH into tan theta. Now BH is the constant, you know the value of it. Substitute that into tangent of the theta you can take. You can get the applied magnetic field. Alright. Now the formula is given here. P upon M is equals to YEP in the bracket L plus D by 2 1 by 4 L raised to 4 B square. So these all the parameters which are required to determine the charge to mass ratio of the electron. We are aware. Now substitute it in the formula and try to get the value of E by M. Experimentally you can find out, theoretically you know the value, compare that, that will be your result of the experiment.